Alright, so before we move on to Rolle's theorem, let's take a look at a couple more examples of the mean value theorem. So to do the mean value theorem, very simple. Remember, you want to show that the function is 1, continuous on a closed interval, and 2, differentiable on an open interval. So if we take a look at number 2 right here, well, I know that the function is not continuous at -1. I do have a domain restriction, x can't equal -1 there. But that's outside of my domain. So this function will be continuous on this domain. And differentiable as well, because there's no bumps or holes or jumps or asymptotic behavior in that domain as well. So when we're writing this out, so we're going to write our sentence. We're going to say that MVT does apply. It's a little bit wordy, so we're going to say the function f of x is continuous on, write out the domain, don't go a, b, and differentiable, and you can abbreviate, on the open interval -1 to 2. Therefore, we can say MVT applies. And somewhere, write out what it means, and somewhere on our domain, again, hard bracket or soft bracket, either one's okay, that somewhere on this domain, and this is the way I like to write it, the instantaneous rate of change equals the average rate of change. You might recall, for example, number 1, I said slope of the tangent line equals the slope of the secant line. I like that, but instantaneous rate of change in AROC is a little bit easier to remember. So that's what it means for us right there. So that's it. Remember, what we're saying, is that this says that the slope of my tangent line equals the slope of my secant line. So now we just have to find out where this occurs. It doesn't take much. That's it. That's all you have to write. So to find out where it occurs, remember my rule, IROC equals AROC. So we're saying that the derivative has to equal the slope, f of b minus f of a over b minus a. That's our rule. This is our rule for MVT. And there's your a, there's your b. So we're going to first take the derivative. Quotient rule. Don't be afraid. Use quotient rule. I'll do it off to the side here just for some space. We're going to get low d high minus high d low all over the bottom squared. And if you simplify that, oh look, the x's cancel, we just get 1 over x plus 1 squared right there. So that's what this becomes. 1 over x plus 1 squared equals f of b, which is 2, minus f of a, which is -1/2, all over 2, that becomes plus 1/2. Alright, so simplifying this is not going to be the prettiest in algebraic, so we're going to go a little bit slower here. To find f of 2, I just plug it in. This becomes 2 over 3 minus, do a little bit of math, plug in -1/2, we get -1/2 on top. On bottom, what's -1/2 plus 1? Well, that's positive 1/2. All over, and I'm going to say this is 5/2. This cleans up pretty nicely. We get 2/3 plus 1 over 5/2. And now I'm going to use my LCD. Ready? My LCD here is 6, so I multiply top and bottom by 6. Ooh, that's the hardest thing you do. Look, calculus, easy. Algebra, hard, okay? People always say calculus is hard. Nah, calculus is easy. Algebra is the hard stuff. X plus 1 squared equals, if I multiply through by 6, we're going to get 4 plus 6 over 15, which is 2/3. And if I want to solve this, there's a couple ways I could solve this, but the cool way to do it is just to flip both of them. If I flip both of them, I'm just saying x plus 1 squared is 3/5. Therefore, I can now solve it. X is equal to plus or minus the square root of 3/5. That should be 3/5. That should be 3/2. There we go. 3/2 plus 1. It's a long little fraction bar there. Check your domain. Negative 1/2. Well, I'm not going to want this one. So remember, check your domain. So x would equal the square root of 3/2 plus 1. Try this one again. You want to get good at this one. You're going to see one of these definitely on a test or a quiz, okay? It's knowing how to work with fractions and stuff. Don't be afraid of those. They don't bite anymore. All right, so let's take a look at number 3, our sine function right here. So let's take a look here. Sine function. Well, we know sine between 0 and pi. If I were to graph sine between 0 and pi, it looks like this. Definitely continuous, definitely differentiable. But what I want you to notice is, what can you tell me about their secant slope there? It's going to be 0. So we should anticipate a 0 slope right here. So let's go ahead and do MVT. This is continuous and differentiable. So we're going to say f of x is continuous on the closed interval 0 to pi and differentiable on the open interval 0 to pi. Therefore, MVT applies just like we did with rolls. Remember we did rolls? And somewhere, say what it means, somewhere over that rainbow on 0 to pi, the instantaneous rate of change has to equal the average rate of change, which we already know the average rate of change is 0. So that's MVT right there. All MVT guarantees that at some point that the slope of my secant line has to equal the slope of my tangent line. At some point, those slopes have to be equal. That's what MVT guarantees, that we will have equal slopes. And now we just have to find out where that occurs. To find out where, we want I rock to equal A rock. If you can master this, you rock. I'm pointing at you. So I rock is just my derivative. A rock is my f of b minus f of a. So f of pi minus f of 0 all over pi minus 0. And I'm going to do a little bit of work. So cosine of x, we get f of pi. Well, what's sine of pi? Well, that's just 0. Sine of 0, 0 over pi. And it kind of looks like somebody with buck teeth or something like that. Okay, so we know that cosine of x has to equal 0. So where does cosine equal 0? Pi over 2, 3 pi over 2. But again, check your domain. Domain don't from 0 to pi. I don't care about that one. So it occurs at pi over 2. So what that tells me is that pi over 2 is where my slope is 0. Pi over 2 tells me where my average rate of change equals my instantaneous rate of change. In other words, it tells me where my slopes are equal. This tells us where the slope of our secant line equals the slope of our tangent line when they occur. All right, so go to part 3, and we'll definitely talk about rolls. It's not a very long lesson after this one, okay? I'll see you guys then. Bye.